Now, let's move on to some tall buildings. We have talked about bridges, we have talked about the arenas, and let's move our attention to tall buildings. And one of the tall buildings that stands out as a differentiator from the tall building design concept of that time is the John Hancock Center. I'm sure you have all seen its design. So this is made from brace tube, as you can see clearly on the elevation of this one. And this is the innovation or invention by Dr. Fazlur Khan, who created the tubular system together with some other people, but he definitely created this one, the brace tube concept. And this one, at that time, was the tallest building. This was very efficient, because when you have a tubular system like this one, tall building, then you have a problem with the shear lag. Because when you have lateral loads, wind loads, for example, then the tubular system will tend to deform, and then you will have a shear lag between one face to the other through the normal walls. So he put the diagonal bracing to take care of that shear lag, and that made it possible to reduce the drift and also make this tall building possible at that time. And also architecturally, the architects liked it because it added a kind of a strength to the structure. You can see it, and you can see it's strong, it's stable, because the diagonal bracing sort of exhibits that. On the right hand side, which I will also talk about, is the Sears Tower, or Wills Towers, which was built few years later, designed by the same designer, using a slightly different modified version of the tubular system. But John Hancock Center is the one that we will talk about first. So when he was proposing this model, he famously took the designer Dr. Khan took bamboo with him to showcase how a tubular structure like bamboo can take the bending very well, because inside it's hollow, where you can put the building or the occupants, and you can put the tube around that. And then to make it sort of stable, then the tube was braced by the diagonals. So the tubular concept with the diagonal was made possible at that time, and it became I would say the core system for many tall buildings to come later. And this is the building during construction. So it's at that time it was constructed in steel. Steel was very popular in US, still is, for tall buildings. So it was constructed using steel columns, floors, and then braced by steel braces as well. And then you can see here how the lateral loads were carried through, once again, like I mentioned, as long as you can create the force flow in compression and tension, the system becomes efficient. If you don't have these braces, you are going to induce bending into the beams and columns, and shear, and that's always more inefficient than having direct force transfer through compression and tension, and those diagonals help to do that. And the right-hand side is a small, ETAPS model to show the concept of the same thing. So, like I said, this is a truss core, steel tube, and which is central core. They used thousands of tons of steel, and the floor area was quite large. And the wind, it was designed for a very high wind velocity at that time. In fact, Dr. Khan also helped to develop the wind acceptable criteria at that, and wind tunnel test procedures and so on during the design of this building, which was the tallest at that time. And a lot of those things still carry through. And it was 350 meters at that time when it was completed, and 100 floors, so it was very, very tall. And these are some of the drawings from that I also already mentioned to you. So you can see here, one of the challenge for the architects and the builder was that the floors were changing the size every floor. So there was no typical floor. So they had to adjust the drawings, adjust the exteriors, have to adjust the interior plan, and each level because of the slope of the tower itself. And it became, Chicago has been a lead in tall building design for a long time. And this was one of the icons of the Chicago, that when you think about Chicago, you think about the John Hancock Center and also the Sears Tower or the Willis Tower, it is known now. New York and Chicago were the two places where most of the earlier tall buildings were built. And this is about the designer. I think most of you, almost everyone knows about Dr. Fazlur Khan. Unfortunately, he passed away at a very young age, but he designed this building when he was only 38. So he was very young when he proposed, and he was only one of the few engineers who became a partner in the SOM company, because they were architects mostly, but he was so good that he was invited to be on the top team at a very young age. So he designed several tall buildings after that, and he was very passionate about this particular project. In fact, you will see here. Yeah. So this is a small video.
And then for Mr. Khan, this building became the yardstick of what every skyscraper was measured upon. We talked about things that he tried to compare it to, like the Eiffel Tower. We talked about the Washington Monument. And he felt that this building was in that class. This was a monumental building. And he told me that as long as he's alive, this will always be his favorite building. And I think it was.
So that's how this building is iconic in its form, still is, because not many buildings of this size in this structural form have been constructed afterwards.